Hello everyone and welcome back to the series of Digital Logic Design or Digital Electronics. Today we will study signed complement method, which is used to represent a negative number. We know that complements are used to make addition simply by changing subtraction into an addition process. Now we will use the complement to represent a negative number. Signed complement method. In signed complement method, we find complement of a given binary number to find its negative equal number. And here we don't use sign bit. And in this type of method, we use two type of representation. First one is signs 1's complement and the second one is signs 2's complement. Now we will study signs 1's complement. This method is used to represent a negative number in binary form. Let's say we have a number 9 which is given by 0, 1, 0, 0, 1, and this is in unsigned form. Now in signed form, plus 9 will be same as 0, 1, 0, 0, 1, and now for minus 9 we will take 1's complement of 0, 1, 1, sorry 0, 1, 0, 0, 1, and this will be 1, 0, 1, 1, 0, and 1's complement can simply be found by inverting all the bits. 1's will be changed into 0 and 0's will be changed into 1. Now we will calculate the weight. In signs complement method, the weight of the MSB bit is taken as negative. Like the first bit weight will be 2 power 0, next 2 power 1, 2 power 2, 2 power 3, and this will be 2 power 4 and the sign will be negative. Now if we calculate, we will have 2 power 4 into 1 plus 0 plus 2 power 2 into 1 plus 2 power 1 into 1 and again 0, and this will be minus 16 plus 4 plus 2, and this will give us a minus 10, and adding a 1, because we are using signs 1's complement to find the exact answer, we will add 1 and this will be minus 9. So this will be the representation of minus 9. Now if we have another unsigned binary number 25 and its binary will be equal to 0, 1, 1, 0, 0, 1. Now its plus 25 or in the signed form will be the same as 0, 1, 1, 0, 0, 1, where the minus 25 in the 1's complement representation will be 0, 1, 1, 0, 0, 1. Now if we calculate the weight, first of all we will assign position and weight, that will be 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4 and 2 power 5, where MSB will have weight of minus, so it will be minus 32, and this will be a 0, again 0, then we will have 4 plus 2 and then 0, and this will be 4 plus 2 is 6, 6, and this will be minus 26 and plus 1 of the 1's complement method, this will be minus 25. So this will be the representation of minus 25 using signs 1's complement method. In sign 2's complement method, for representation of a negative number, we simply take sign 2's complement and the weight of the most significant bit as taken as negative. For instance, we have 5 which will be given as 0101 for unsigned number, and for sign positive number it will be 0101, and for sign negative it will be 2's complement of this, which will be 1101. Now if we calculate the weight, it will be 2 power 0, 2 power 1, 2 power 2 and minus 2 power 3, and this will be minus 8 plus 2 plus 1, which will be minus 5. and this will be the easiest way to represent a number using sin 2's complement method. Another example can be 15, which will be 0, 1, 1, 1, 1, and plus 15 will be 0, 1, 1, 1, or the minus 15 will be 2's complement of this number, which will be 1, 0, 0, 0, 1. And now if we calculate the weight, it will be like 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. So 2 power 4 is 16, and it will be minus 16 plus 0 plus 0 plus 0 plus 1, and this will be minus 50.
Thanks for watching the video and stay connected for more interesting videos.